sure that we go this way and give them a chance to see this light flash. So we get a little bit of assistance there, of the light. And let's see how this works. Make sure that you see the flash. Very good. You can going to see another 25 joules going through this light bulb. Very good. Oh. Yeah. Oh, yeah. Your hand is in front of your mouth, sir. Yeah, that's okay. Thank you. Very good. Did you see the flash? Did the assist go? So that's the idea of photo flashes. So you dump a lot of energy in a very short amount of time, and you get a very bright flash. Professor Edgerton at MIT became very famous for his flashlights. He invented flashes that can handle way more energy than this flash, and they can dump that energy in less than 1 microsecond. And so this opened up the road to high-speed photography, and that made it possible to study the motion of objects on timescales of microseconds and even shorter than that. And I'd like to show you some of the pictures that were taken with Doc Edgerton's flashes. The first slide. You see a bullet coming from the right, going for a light bulb. The exposure of this picture is only 1/3 of a microsecond, during which the bullet probably moved only 1/3 of a millimeter, so it looked like it's completely standing still. And the bulb is heading for disaster, but it doesn't know that yet. The bullet moves in 100 microseconds, about 8 centimeters, and the next picture is taken 100 microseconds later. Again, 1/3 of a microsecond's exposure. So if we can look at that, there you see. So the bullet now just penetrates the light bulb, and then the next picture is another 100 microseconds later, and there you see the bullet emerging from the light bulb. And this light bulb has hardly realized that it is broken. But it's beginning to dawn on it, and then the next slide is one wonderful picture of a boy who is popping a balloon, and you see half the balloon doesn't even know yet that it is broken. Doc Edgerton also, that's enough for this slide, he also developed a lot of strobes. A strobe, I have one here, is an instrument that repeatedly discharges energy over a light bulb, and so you get repeated flashes, and that then gives you an instrument like this. You've seen them in use. They are being used at airplanes, just for warning signals. And you've also seen them on tall towers near airports, also warning signals. But there are a lot of more things you can do with strobes. And later in 802, I will show you, for instance, that you can measure the rotation rate of motors with flashlights, with these stroboscopes. And motors are going to play a more important role in 802 than you may have guessed before you took this course. You can also measure with strobes the rotation, the speed of your record player, if you still have one, and then you can adjust it so that it just has the right speed that is required. So there are a lot of things you can do with strobes, and some of which we will see also in 802. So now I return to my capacitor there. And let's see how it is doing. Oh boy, we're close to the 3000, which was my goal. It takes, you see, a good 15 minutes to actually reach the 3000 volts on this huge capacitor, and to get in there the energy, the 450 joules that I wanted. And why is it that I want to show you this? Well, I want you to appreciate the idea of a fuse. You have lots of fuses at home. A fuse is a safety device. A fuse is something that melts, something that breaks, if the current that you are using is too high. suppose you have a short, electric short without realizing it, in your desk lamp, and a very high current could start to flow, then the fuse will say, sorry, you can't do that, the fuse will melt, and then that prevents you from a disaster which actually might give you a fire. And we already showed, in a way, the idea of a fuse, because when we broke this light bulb, that was, in a way, a fuse. We dumped too much energy through that light bulb, and so the light bulb itself was already like a fuse. This is really more like a fuse that we are used to. It is we have a wire there, which is an iron wire, which is 12 inches long, and it has a thickness of 30 thousandths of an inch. And we're going to dump the 450 joules through that wire. So the idea is very much like we had the photo flash. We have all this energy in the capacitor, and instead of dumping it through the light bulb, which was this system, we now have here a wire, and when I throw this switch, the energy will go through the wire, and chances are that you may see the wire glowing a little bit, and then it would melt, and that would then give you the idea of a fuse. And it's also possible that after we've done that, that there may still be energy left on this capacitor, and I can show that to you too then, because I can short out the two ends of the capacitor and see whether we still see some sparks, which would indicate that there's still some energy left. So if you are ready, I'm always a little bit scared with this demonstration, not so much about what's going to happen. That thing will probably just melt and maybe we see a little bit of light. That's not the issue, but I'm afraid of this baby because that has now a tremendous amount of energy. So I stopped the charging. So let's do that. And if you're ready, then I will try to dump all that energy through this wire. 3, 2, 1, 0. This is the way a fuse works. This is very effective, as you see. And if you hear this happening in your basement, then, well, maybe that's a fuse. We can now check whether there is energy left on that capacitor. Maybe not very much, but it's unlikely that everything was dumped in the iron, so let's see whether there is some left. I'm going to short it out with this conducting bar and see whether we can get a spark. And we can. So there's still some energy left. Okay, see you Friday.